back to our product managers and or people who are working on Kubernetes and hopefully making it better. Okay, so yeah, if you have any questions, any feedback, please let me know on Twitter, which is @Satanism. It's really small screen, so I'm gonna just zoom in a little bit here. Yeah. Whoop. And if you want to find more information, well, that went away again. You can go to my website, which is satanism.me. Okay. There we go. Oh no. I think you need to stay there. Just like the old antenna TV days where you have to stay in a specific position to get reception. Yeah. All right, well, let's go on. So, quick question. How many people here are already familiar with Kubernetes, using it? Using it today? Oh, wow, very nice. Okay, very cool. So I think it's, without saying, Kubernetes is kind of like becoming a de facto standard in many of the new application platforms, and especially with managing microservices type of application. And it's very important to actually understand how it works, to think and be able to prepare for what is beyond what we're using today. When I started using Kubernetes, maybe like 2-3 years ago, this is what happens, right? You build a container image, you write a declarative file, like a YAML file, to say what it is that you want, and Kubernetes, through its master node and its scheduler, is going to run in what we call a reconciliation loop, and it's going to try to make your desired state into something of a reality. So in this case, if I want to deploy 2 instances of my container that's self-contained with the runtime and the application in it, then the reconciliation loop is going to say, okay, do I have 2 instances of something running in my cluster somewhere? And if I don't, I need to assign and schedule the application to be running on one of the nodes, and I need 2 of them. And once each of the nodes receive this kind of instruction, then it's going to start up the application, and now you have the desired state matching the actual state. But I'm not sure if anyone here actually take a look inside of how this actually works. When I talk about Kubernetes and deployment for Java developers, this is as much as I go in depth for. But to truly understand the power of Kubernetes and what we can build on top of that, we have to understand the fundamental building blocks in it, right? Specifically, while Kubernetes is very good for deployment and stuff, it's a control plane for your application. We have this well-defined API that we can use. We have the concept of using it as a control plane, and we can create all of these desired state. The true power of Kubernetes is this. I hate to say it, but please don't quote me on it. Think about your very old traditional ERP system or document management system, right? Think about how those things work. You define a document of certain types, and then you put, different people in different line of work, we put our document into the system according to that specification, and then it gets sent through a workflow where another physical person do something with it, and then you pass the document on to another person. Or maybe you create new documents from it. For example, if you want to order something, like order new widgets into the warehouse, you don't just create an order, but maybe you have to enter and create some other forms. And then ultimately, everything gets synchronized. Now think about this in this context in how Kubernetes is working behind the scenes. When I define a deployment as a document, I physically put this document into Kubernetes, which then gets stored in their etcd database. And then rather than having a real person who's behind the scenes and doing the deployment for you, there's a controller. This is all automated. The controller, its job is to read this document and see what needs to be reconciled and what needs to be done next. In this case, when I push a deployment to Kubernetes, the deployment controller is going to create a replica set that matches the descriptions of the deployment. Okay? And then once you have a replica set, this is just as good as a document. This is just text that's being stored somewhere. And we pass it to the replication controller, who is also running a loop to say, hey, do I have new replica sets I have to deal with? If there is, I'm going to go ahead and see, okay, this is the desired state of the replica set. What do I do next? And the job for replication controller is to create pods, which are the instances that will be running your application. However, at this very moment, this is still just documents. The pods are just documents that exist in an etcd database. Nothing actually has been started. And then, of course, behind the scenes, another script or another controller is going to wake up and say, oh, I have pods that hasn't been assigned to any of the nodes I need to run it. And so the scheduler is going to wake up and say, where do I actually assign these pods? Where do I assign this workload? And then it's going to say, based on heuristics or based on your own scheduler, it's going to say, let me write this back to the document again, and let me put one of the pod to node 1 and another pod to node 2. Again, think about this. At this very moment in time, they are still just documents. Nothing actually has been started. And finally, each of the nodes, they have something called kubelet. And its sole job is to read the documents and reconcile and make sure that this becomes a reality. And so the kubelet on node 1 is going to say, oh, I have a new pod. I need to run this in my node. And so let me go ahead and start it. Similarly, the kubelet on node 2 is going to do exactly the same thing. And once the kubelet has started your application, starting the pod, then it's going to rewrite the document and update the status and tell you that this is actually running or if it's actually failing. Okay? This is the entire workflow behind the scenes, and this is how we can get from a deployment, and after like a second or so, that we get to see the actual running application. Now, this is important because if Kubernetes building blocks does not allow you to do what you want to do, then you can actually write your own resources. You can write your own definitions. Think about this as, if I don't have the tools I need to create new tools. But these tools have certain descriptions. There are certain desired states. And for these desired states, I can define these in what we call CRD. So this is a very simple CRD I took it from one of my coworkers' project called Agonist. So Agonist is a project that is designed to deal with game servers and game server deployments. Because game servers have very different deployment strategy than a regular stateless application. And so to deal with this, rather than using the existing Kubernetes deployment and pods and stuff like that, it has to create new strategies. It has to have a new desired state. And so they create a new CRD for it. In this case, this is called the game server CRD. Okay? And the CRD can have different attributes. You can define the schema. But ultimately, you can also have the actual resource that uses the CRD that you defined, right? But then what's very important is to be able to run the controller that will be able to read the CRD and reconcile, and then using the building blocks that Kubernetes provides you to build out this actual system. So for example, in this case, the game controller, once it reads the CRD, maybe it actually uses the deployment. It just controls it different way. And deployment is going to create a replica set, and replica set is going to create a pod, and this kind of trickles down to the actual deploy state. And this is very important because CRDs allows us to have a way to define higher level concepts. When the building blocks don't work anymore, we gotta move higher. When things are getting too complex, we tend to find abstractions that we can deal with them easier, right? And most of these controllers or operators, I call it, are written in Go. And since we're in J4K, right, I understand that there's an increasing interest to actually write some of these controllers and being able to deal with these higher level concepts with the JVM-based operator. So rather than writing this in Go, it's actually very possible to go through this entire phases and understanding and using CRD by using something that's written in Java. If you're interested in this, definitely more than happy to chat afterwards, okay? So now that we understand the concept and the basics, let me just move on to what do we do beyond just deployment, right? Kubernetes is very, very good at allowing you to orchestrate a deployment across your cluster, give you the ability to do some service discovery, but there's just so much more things that we have to deal with once we deploy our microservices application. For example, we need a way to deal with load balancing strategies. Okay? By load balancing, I don't just mean round robin, because for my entire enterprise career, when I hear load balancing, I go to round robin load balancer. And that is actually not the best way to do it. So you gotta think about the different load balancing strategies for your application. It depends on how you define the load, right? But how do you actually do that in Kubernetes? You can't really do it just out of the box. You need additional facilities to help you load balance with different strategies. We need ways to have fault tolerance, right? We need the circuit breaking. If you do have a microservices deployment, we need ways to actually have a visibility into the entire system to be able to see, for example, the traces or the monitoring metrics, like the latencies, the 404s and the 200s, how many of them are you getting back? How do you do any of that? In the Java ecosystem, we have a lot of open source tooling. So in this case, we kind of fall back to some of the things that we built directly into our application. For load balancing, right? A lot of us kind of chose to use client-side load balancer. But is that the best load balancer that you can use? Well, it depends. It depends on whether you have control or not. If you have full control over the consumers who you're trying to load balance, then that's fine because you can update the code and update it with new load balancing strategies on the client side. But if you're across the network boundaries, if you're across organizational boundaries, say it's another line of business, or it is something that's coming from the mobile apps, then it does not make any sense for a mobile app to use client-side load balancing. In this case, you have to move to a proxy-based or a server-side load balancer. For circuit breaking, in the Java ecosystem, we have Hystrix from Netflix. For distributed tracing, we got Brave and Zipkin or Jaeger for tracing. And many other things, right? But one thing that you have to keep in mind is that all of these things are things you have to deal with across your entire organization for every single one of your applications, not just for the Java ecosystem, but also for any other languages you're running, right? So what that also means is that this is great if you have a single framework that can take care of all of these things. But what if you don't use the same framework? What if you're using different languages? And this is the higher level abstractions that we are able to build on top of this entire Kubernetes ecosystem using the concepts of CRDs, defining new concepts and higher level abstractions. And the first layer that we're going to talk about is Istio, which is the service mesh. So the service mesh is this higher level abstraction that allows you to manage and declare the desired states of your load balancing strategy across your services. It allows you to define your desired states of tracing and monitoring strategies across your services as well. Okay? And it's an open source project coming from Google, IBM, and Lyft. And it's designed to be multi-environments, multi-platform, but it is targeting Kubernetes first, right? So this is a platform that works on Kubernetes today. And what it does is that, similar to how we are using Kubernetes to define and declare our deployment desired state using the control plane, in Istio, we're using the CRDs and YAML files to define our desired states for service communication, for routing rules, for retry rules, for circuit breaking rules, right? So that you don't have to build this into your application directly, but you can control it from the outside. I'm not going to be able to go into the details of how this works simply because of the time. But if you're interested, I'm more than happy to chat with you afterwards. But basically what we can do is to take a traditional microservices architecture like this, where we have all of the things that we have to deal with, the cross-cutting concerns that we have to deal with. We take from your application, from these individual libraries that you put in your application, we extract it, we take it out, okay? And we push it to a sidecar proxy in Kubernetes, and where we can manage the proxy through a single control plane, which happens to be called Istio Pilot, okay? And so basically, whenever you want to change a routing rule, rather than modifying the application configuration or the app, the jar file itself, what we can do is to be able to declare this, push the declaration to Kubernetes. It's going to be picked up by Istio Pilot, and it's going to propagate the configuration down to each individual proxies, and then apply the type of load balancing strategy that you need. Let me just do a very, very quick demo of this, see if I have this up and running. So I'm going to switch my, this is very, very small, isn't it? Let me do this one. kubectx, let me go to my demo cluster here. And I think in my demo cluster, I have two things running right now. I have a work server. Okay, so I gotta have two services. It's microservices, era. So I gotta have two microservices here. They're very, very small. They got nothing built inside. It's like 20 or 30 kilobytes of jar. So, and this is all written by just pure JDK stuff that you should probably never use. Anyways, so we have work server. What is work? Work for me is just going to a sequence of meaningless meetings that has no outcome. And so to have that, I have meeting server. Okay? So what does the work server do? The work server will code, I don't know how many meetings you go to, I usually live code this, by the way, but I don't have time to do that today. But what does the work server do? Well, I don't know about you, but I go to 4 meetings a day, right? So that's when I'm working, pretty hard. So with this, what we can do is to, let me just find my ingress here. So Istio system. So what Istio provides you is a way for you to define your incoming request and being able to route it to the backends in a way. So I can go and route all of my requests, for example, through a single ingress gateway that's coming from outside of the cluster. And if I curl this, go to work, let me see if I can do this. Go to work. Does it work? Yeah, OK. Yeah, so we can see here. So I don't know, what you do at work, but in this case, for me, personally, when I go to work, I sleep, when I go to a meeting, I sleep for 250 milliseconds. It's called micro sleeps. Okay, so if I go to 4 meetings, I sleep for one second. Of course, I sleep more than that. But yeah, just for analogy here, right? So we got 4 meetings, and it's about 1 second, which is fine. And this is all going through Istio. This is going through Istio through the things that I defined. What are some of the things I defined? Well, first of all, there's something called the gateway. The gateway defines the incoming request and a way for you to take incoming requests from outside of the cluster. Okay? So if you are talking within the cluster, you don't need the gateway. But in this case, I'm exposing the work server to outside of the cluster so I can get it from my laptop. Then I have to define a gateway. A gateway basically can do virtual hosting, right? We're using YAMLs to define what the gateway should look like. And ultimately, it becomes this IP address that I can hit. And then you might be asking, well, how do you actually route the /work to the actual backend services itself? Well, I can define something called a virtual service. So a virtual service basically defines where do I want to bind this to? Do I want to bind this to an external gateway, or does this has to be internal? And I can define matching rules, right? Very specific rules on whether it matches certain URI or whether it matches certain headers. And then I can define the routing rules behind this, right? So I can say, if the URI prefix is /work, then I'm going to go to the work server, which is the actual service running in Kubernetes behind the scenes. Now, what if you have multiple of these services or multiple versions of work in this case, right? Some days I work harder than the other. So when I work harder, I go to 8 meetings a day, okay? So let me go ahead and apply my second version of my application. So I'm going to say v2. Okay. Now, typically in Kubernetes, when this happens, you don't really have control over how you can load balance. Because the load balancer in Kubernetes, thank you. The load balancers in Kubernetes is load balance based on connection, but not based on request. So it's something you have to be worried about, just think through. Right? Let me wait for this to come back. Wow. I don't have any jokes. That was my only joke that I just heard.
They're already better than Paul's.
Oh no, is it me or is it the thing? Wow. Well, you can't really do much without the screen for a live demo.
It's still causing the problem.
Yeah. No, we need some retries and fallbacks right now. Circuit breaking. Oh, there we go. Oh, thank goodness. All right, cool. So let me try this again. So I'm going to curl work. Oh, no. Wait, I think you need to stay there. Wait, come back. Come back. Wait, come back. Yeah. Now, this is a really, really good demonstration of your physical network. Things could be lost. Packets could be lost, right? Connections could be lost. And hopefully, you don't need a physical person to fix it. And you have retries that you can just retry the request and everything will just go through. Is that the, yeah, well, we'll see. While they're doing this, I'm going to put this on a while loop. It's something you should never do. I'm going to say while true, do, and done. I'm going to go into an infinite loop. Yeah. Yeah.
It works for Apollo, for one of them Apollos, right?
Yeah, is it working? Okay. Well, that's too bad because my demo doesn't work. I was hoping that I get the demo working before. Oh, okay, I think it's working now. All right, so, let me do this while true and whatever, and let me just apply some of these things. Apply F. So what we can do is to hopefully deploy 2 different versions of my application, and being able to route between the 2. So one of the ways we can do this is by using, again, a declaration here. So I'm going to say v2 10p. Oh, my goodness.
Sorry.
Yeah, I don't know what to do if the monitor does not work. There we go. Maybe it's me. Maybe it's the computer. No. Okay. Good.
No, it's not your computer because I have you on my record. It's that
Yeah.
HDMI.
Okay. Well, let's see if this gets any better. So here we have the route. So basically, we're defining the virtual service again, and then we can do different destinations. And each of the backend, in this case v1 and v2, we can assign different weights. And so then we can traffic route between the 2, right? And think about this, what it helps you to do. It helps you to shift traffic across different versions. It helps you to do a canary release. If you have a new version of your application, you're not so sure about it, maybe you want to ramp up traffic, you can give it 1% of the traffic, and then slowly ramping it up over the next couple of hours, okay? So let me see here. Okay, so I think right now I have all my traffic shifting to version 1, which is when I go to 4 meetings a day. And I don't know if I want to work hard for the first week here. So let me go ahead and just go shift this up a little bit to maybe, I don't know, let's say 20% of this. And by the way, the weight is just you add everything up. Yeah, 80 plus 20, that's 100, and then 20% is the 20 of that, right? So I can just go ahead and declare it. And just remember what happens behind the scenes. We're using a CRD that's specific to Istio. We're applying this into Kubernetes. I'm just putting this into their document store. And then behind the scenes, the controller wakes up. They reconcile the configuration. It pushes down the configuration to all of the proxies. And if the screen comes back, we will be able to see that we're going into the second version about 20% of the time. And if this doesn't work, I'm going to turn my laptop around because the screen is just as big anyways. No? Yeah? Maybe? All right, cool. Well, I'm going to move on. That's okay. Oh. All right, don't move. Don't. You only have 20 minutes left. Okay, good. So anyways, so here we can see that once I started shifting traffic, now I'm going to the new version of my app, which is the one working really hard. I go to 8 meetings a day, and now I'm there. And of course, we can do a lot more, like with retries and everything else, right? So we can define retry rules. You can define circuit breaking rules and stuff like that. Anyways, I'm going to move on a little bit. Now, why is it so important? And what else does it get you? Well, for example, even in this very basic application, I can promise you there's nothing in there. I don't have any extra libraries. It's just about 40 kilobytes of just straight up JVM code with no external libraries. But this is what I can get you in Istio. We can get, for example, metrics. So if I go to localhost 3000, and this dashboard comes with Istio demo installation, this beautiful dashboard right there, like everybody else's monitoring dashboard that doesn't actually exist. Yeah. There you go. Should I just, is there like a, I don't know. Yeah. Okay, no problem. There we go. All right, good. All right, so this dashboard that just went away, like like any other dashboard, it's gonna show you some of the metrics of the services that you have. Similarly, without adding any additional components, we are able to get traces to show up as well. Okay. Don't touch it. Don't. No. Yeah. No. Oh. Okay. tell you what, I'm going to do one thing. Maybe this is going to help. I have a feeling the cable is now up to the task. I'm going to lower the resolution a little bit, just see if that helps. Sometimes the cable can't carry the bandwidth, and I think that's probably what's happening. Okay, cool. So let me try this out. You gonna change it now, or you gonna change it later? All right, I'm gonna keep going. All right, cool. So this is the dashboard that we can have right off the box with the Istio, right? So for example, I can go into the work server, and I can see the QPS that was actually creating from my application. And there was a little hiccup here. You can see the request didn't go through, and it came back up, right? So this is just out-of-the-box metrics that we can add. Actually, I'm doing pretty well right now. Okay. Yeah. All right, cool. The other thing that we are able to do is, of course, trace. Without much of the configuration that I need to add to my application, I can go ahead and open out my trace console here. Now you can use Zipkin, and in this case, they're using Jaeger. And I can just go ahead and find my traces. And this is the code that came in with work, and if I click into it, I can see all of the different additional codes I have made, and I can also see how much time this took, right? All of these things are additional capabilities that's being added by Istio, all right? And this is all abstracted away from the application. Now the true powerful thing that you can do here is that if you think about Grafana, Prometheus, and Zipkin, or Jaeger, these are platform services that help you to visualize your metrics and understand your application deployments and how the traffic is routing. However, think about what Kubernetes do for you. Kubernetes abstracts away the underlying virtual machines and all of the infrastructure, so you deal with the higher level concepts. In this case, Istio is able to do the same thing, where if you're using Istio, it's very possible that you replace some of these platform services behind the scenes as well. So you're not locked into a single ecosystem, right? You deploy and manage your application exactly the same way, but you can replace some of these components because they abstracted away from you. And so, for example, you can use cloud service providers to store your traces or your monitoring metrics for different providers, for that matter. Okay? And more importantly, if you ever want to use MLTOS, mutual TOS authentication, Istio can add it for you automatically to your apps without you having to modify your application, which is really nice. I don't know if anyone here just love to use custom certificates in your Java applications. Yeah, everyone loves that, right? So if you don't want to deal with it, you can use Istio. Anyways, so moving on, in the next 15, I got 15 minutes, right? So in the next 15 minutes, I'm going to talk a little bit about what else we can do based on this concept. When I first showed Kubernetes, it was very, very cool. It is still very, very cool, right? But when I show how you can deploy 20 instances of something onto a cluster in like a second, many people are very excited about it. But now, when people are starting to use it, we always want to make things easier. So when we're using Kubernetes and doing the whole development cycle, this is what we find. We need to write the code. I mean, obviously, you got to write the code regardless. But then you have to build the Docker container. And then you have to upload the image to the registry. And then you have to write the YAML files, a lot of YAML files, to do the deployment. And then you've got to figure out the way, like in Istio case or in Kubernetes case, you have to figure out a way to expose your service to the public internet. And then you have to figure out how to scale out the workload. Maybe you want to do serverless and you want to scale this down to 0. And then you got to do the metrics, the trace, and monitoring, all that, right? So there are a lot of different steps you have to take just to get your application into the cluster. As a developer, what we may want to do is just write the code and just deploy, right? That's all we really care about, right? Do I really care about the Docker container image? Probably, maybe not. Do I really care about how to write the deployment files? Probably not, right? Do I want to write an autoscaler that help me to autoscale my application down to 0? Probably not, right? And so we need higher level abstractions, and we can do that with Kubernetes. And this is where Knative come in. This is a set of building blocks, again, a set of CRDs and controllers and operators that help you to define your application at a higher level. And they have 3 different primitives here: build, inventing, and serving. So build defines how you can build your app that will automatically take your source and create a container for you. Eventing is a way to deal with these events from messaging systems like Kafka or Cloud PubSub. so that we can spin up and handle your events as the events are coming in. And we can automatically scale out the consumers when you have more events coming in. And serving is just a way for you to take the request from HTTP. Okay? So there are all of these building blocks that's designed to help you to abstract away some of the, all of these things that we have to do. There's a lot of it, right? We don't want to do, right? And how this works is, again, we're using CRDs to define these higher level concepts. We're building on top of the Kubernetes platform. That's why it's called Knative. And then we're using Istio behind the scenes. That's why Istio was important. And this is used as a layer that helps you to route your traffic. And then we build on top of the primitives on top of these two layers. Okay? And what it can help you to do is something like this. Okay? Rather than deploying and writing the YAML files for your deployment, and figuring out your load balancing strategy, and then create a service and load balancer, and deal with TLS connections and whatever. This is what you do in a Knative type of deployment. So I'm going to switch my cluster to something that has Knative pre-installed. And let me see what's running here. Get pod. And I have nothing. That's good. So what I'm going to do is to go to my other demo directory here and go to image. Okay. So with Knative, what we can do is to basically, again, we use CRD to define something that's at a higher level. And all we are going to say is, all we care about is the container that we need to run and the associated configuration, in this case, the environmental variable. Okay. And by doing this, I'm going ahead and just apply this, give it to Kubernetes to take care of. Knative controller kicks in. And then, ultimately, this is going to configure a lot of things behind the scenes. And ultimately, we get a pod, right? So here, I'm just going to wait for the pod to come up and running. Okay, well, I just deploy a container. You may be saying, well, wait a second. It's not so different from what I showed earlier, right? There's nothing too different about this, except that if I say Knative get K8s VC, so in this case, I'm getting the Knative service, I actually not only get a pod, but I get routing as well. I actually get a domain name, a URL that I configured, and it will automatically infer the name of the service and also the namespace this is in. And I should be able to go there right now, right? Yes, I'm sure you will understand in a few minutes. So in case this was too awesome, let me just show you something else. So if I want to make a change for this, right, all I need to do is to change the greeting here and say hello. And I'm going to go ahead and apply this again. Oh, kubectl apply. And what this will do is, again, not just deploy, but configure my routes, shift all the traffic over. This is all automatic. And if I go back and do a refresh, I can see the new version up and running. This is so cool because there are so many things going on behind the scenes. First of all, if the application is not being used, or if any of these versions is not being used, it will be scaled down to 0. Right? So this is serverless part of it. And if a new request comes in, or you've decided to shift traffic to it, then we'll spin up the application for you automatically. We're automatically configuring the route for you, so you don't have to deal and configure your own load balancer anymore. Like if you're using Knative, this is all out of the box. What we can also do is to deploy directly from source if you want to do that. So for example, here I have, within Knative, we have the concept of a build template or a build pipeline. And a build template is really just a sequence of steps that you want to perform for a build. And there are many different build templates you can do. If you're using Docker, there's a Docker build template with Chronicle. If you're using Jib, we have a Jib build template. You can even use a build template that's using the Cloud Native build pack for that matter, right? So here we have a build template. And basically what that means is I can build anything from source. Again, we're doing with higher level abstractions. In this case, we're turning from source to the image that we want to deploy. And then we're going to deploy it, okay? And that's what we can do in a Knative-like environment. So I'm going to go ahead and do kubectl apply. And in this case, this is a out-of-the-box pet connect application. And what this will do in the Knative sense is to actually kick off a build. So there's a build pipeline going on right here. Okay, I'm going to go ahead and see this build pipeline. And This is all happening behind the scenes through the controllers. We're kicking off the build. We're downloading the source. Now we're downloading the Maven repository, all of it, like 20 gigabytes of it, maybe. Yeah. But it's in the cloud. Yeah, exactly. Yeah. So we're building this Spring application, right? And then once everything is downloaded, you can also configure cache. And it's going to kick off the build pipeline to build the container. And then once that's all done, then we're going to update the deployment for you. And then we'll automatically scale this out. And we configure the load balancer and the autoscaler based on concurrency. And we can scale this out to however many requests you have. And we can scale this in down to 0 as well. And we can do, of course, more. Think about this type of system that's built on top of Kubernetes. So that's why I named the talk Beyond Kubernetes, right? We got to think about what abstractions we can build beyond these basic building blocks. Because there's something that's awesome. Because based on this system, for example, Pivotal has built a system called Riff that's built on top of this entire Knative ecosystem. It's a really nice command line that allows you to do something like Riff function create. Let me see if I can. Yeah. So it allows you to do something like this. Riff function create. In this case, cat, which is one of my demos. I can say which image to build to and where the source is. You press a button, it generates the custom resource for you. It kicks off the build. It goes to this build. Oh, it's still working? Wow. And then this is a lot of things that's being downloaded from Pet Clinic. Oh, there we go. And then it does the build, and it deploys the application, gets you a URL. Oh my God, it's still going. And this is what we code source to URL. Okay? If it downloads faster, then it's better. All right. And then finally, one more thing I'm going to show is called another really cool utility that somebody else showed me recently. It is on GitHub/Google/KF. So it's a little utility that allows you to deploy your application with a similar experience of, say, CF, but using Kubernetes and Knative in the backend. It's a very, very cool tool. Now, they're running through some sample here, but you know what? I'm just going to go ahead and start one. So this is the type of experiences that you're going to hopefully have when you're running a Kubernetes cluster, right? I'm going to go ahead and create a new demo here called J4K. I'm going to create a new, not that one, sorry. Let's add a web starter. So we're using Spring and Spring Boot, right? And I'm not going to add any controllers. It will just bring up the system automatically, okay? And I'm going to go to download and unzip this thing I just created, okay? J4K. Right, again, imagine, just think through how this works behind the scenes. I'm going to say kf push J4K, okay? And what this will do is to upload my source into this build pipeline. It's going to kick off the build by using the build template, okay? All within the Knative environment. Hopefully this has fewer to download. And this actually is, in fact, using the Cloud Native build pack. So this is the build pack from Cloud Foundry they donated to CNCF. And it's going to say, oh, this is a Java application. I'm going to get the JDK. It's going to download Maven. And then, again, configure the services for me. And in a few minutes or so, this will turn from my source into an image without you having to worry about it. And then deploy this in a serverless environment with autoscaler and a routing rule set up, and you're ready to go, right? So this is the higher level abstractions that I think a lot of people are trying to get to by building this on top of the Kubernetes ecosystem. And of course, a lot of these controllers are written in Go, and like I said earlier, there are many people who are interested in building their own operators, their own abstractions in the JVM ecosystem, right? So of course, this, I got this is why I leave this to the last minute, just in case it doesn't work. I can just say, oh, well, that's too bad, I don't have time. But we'll see. All right, so the first one actually went through. Oh my goodness, Pet Clinic took a while to do. So let me say kubectl get ksvc. And here I have Pet Clinic, right? I got a URL. This is built directly from source. This is the first iteration of this. And I should be able to go see it. Now, it's very possible that I don't actually have a Pet Clinic instance running because no one was using it. So we're starting a new instance right now, right? This is serverless. And you might also notice that greeting went away because no one was using the greeting service. So that went away as well. But here is the pet clinic up and running from source, just built directly off whatever I just got. And similarly, here with KF, we got J4K service we just deployed through a command line. And if I say KF apps, I think that's the way to see it. That's the URL that I'm going to hit, right? And this is the app I just created. And of course, I didn't write any controllers, but you get the point, right? You can get source, deploy it from a registry or just from your laptop, for that matter. Whew, that's a lot of demos. So just to recap, before I end this, right? Higher level abstractions. What actually happens behind the scenes? From a service, a very simple YAML file that I defined, a controller kicks in. This is a CRD, so there's a controller. And the controller says, my job is to create a configuration. That's a concept I didn't get into, but just know that it's there. A configuration is going to create something called a revision. Revision is going to, from here, we also create a route that points the traffic to a specific revision. You can do blue-green deployments this way. And then from revision, we create deployment. And then we create Kubernetes service for you, all behind the scenes automatically. And then, of course, from deployment, we create the replica set. And then we create the pod. That's how things get there. And from the route, we create the Istio virtual service for you behind the scenes. So that's also bound to a specific backend and URL. And that's how this whole higher level abstraction all tied up. And that's how we can get from a simple YAML file down to something that's pretty complex, okay? And that is the gist of what you should be looking at when you are doing your own Kubernetes deployment in the future. Okay, with that all said, I think my time is up. So thank you very much for being here. Enjoy the day.